All right, what's the goal for today, people?
Get this done. And I can graph systems of linear equations to determine.
I can graph systems of linear equations to determine a solution. So, we have talked about graphing lines before, right?
Yes.
Okay, so all this is before we were graphing one line, now we're going to graph two lines on the same plane and figure out where they cross. Okay, so important note. The point where the two lines cross is the solution to the system of equations. And highlight that in green. That's not a very good green. Good luck.
So highlight green.
That is a rule. There we go. Now it looks green. Okay, so what's going to happen is they're going to give you two lines. You're going to graph them, and you're going to be able to tell us information based on your graphs. So the easiest way to learn how to do this is to actually do it. Okay, so what happens is they draw this funky symbol. It's called a brace to show that the two equations are to be graphed together. Okay. So the first one is y equals negative 2x plus 5. And the second one is y equals x minus 1. Okay. Does anybody remember what form these are written in? Y equals mx plus b, which is called slope intercept form, which is usually the easiest way to graph it. Okay, so we need to graph these. So let's draw a graph. You mostly need the right side, so you got to go up at least 6 and down at least 2, and then 4 to the right. Draw yourself a pretty good sized graph. Okay, I'm gonna graph these in 2 different colors so that they're easier to see. You don't have to, but you can. At least 4 to the right.
Oh, I do my mind.
Okay, the first one is gonna be graphed in red. So on that first line, first equation, where am I going to start graphing?
5.
At 5. Start at the intercept, right? So we're gonna start up here at 5 and put our point. Okay, how am I going to figure out where to go from there? Down 2, because it's negative 2, so we're going down 2 to the right 1. Now you got to do this a couple times so that you have enough points that they intersect. Okay. What if I wanted to go to the left? Can I go to the left? If I go to the left, I have to go up 2, right? So it stays on the same line. Okay, connect your dots. If you want a ruler, there's rulers in the cabinet. Okay, the second line, I'm going to graph it in blue. On the second line, where are we starting? 1, but -1. Okay, so then what is the slope of the second line? Up 1 over 1, right? Because if there's not a number, there's a 1. So we're going to go up 1 over 1 until we run into the other line.
Wait, are we starting in the negatives because it's minus?
Yes. Okay, so what is the solution to this equation? Other way. 2 and 1. So our solution is just the point where they cross, which is the point 2, 1.
Yeah, I say that now. And then...
Hang in there. Okay, let's try another one. If I can draw my symbols. Okay, x minus 2y equals 2. 3x plus 4y equals 16. Okay, are those in slope intercept form? No. Does anybody know what they are in?
ABC.
ABC is called, you're right, standard form. It was standard form. Okay. It is easiest if you rearrange it so that it's y equals. Okay, so we're going to start by rearranging these. Okay, so x minus 2y equals 2. We want this to be y equals. How do I rearrange this so that y is in the front? So it's just y by itself. You're going to have to divide, but before we get there, you got to move that x, right? How do I move the x? Is it a positive x or a negative x? Positive, so you have to subtract. Okay, that's gone. Negative 2y equals negative x plus 2 because it was a positive 2. How do I get rid of that negative 2 in front of the y? So let me set it earlier. Because this says negative 2 times y, right? So it's the opposite of negative 2 times y. What's the opposite of 2 times? Divide. So we have to divide everything by negative 2. Okay, now this x, there's not a number in front. What is it actually? 1. Okay, so here's the deal. If it makes more sense to write it as a fraction, so like if it doesn't come out as a whole number, just keep the fraction, okay? So this cancels. Y equals negative 1 over negative 2 is just 1/2, right? And then we write down the x. Okay, what's positive 2 divided by negative 2? Negative 1. Okay, so that's our new line that we're going to graph. Y equals 1/2 x minus 1. We got to do this.
Okay.
We got to do the same thing with the other line.
Oh my God.
3x plus 4y equals 16. Okay, what are we going to do to solve this, people? We need to be y equals. What's first? Subtract the 3x. 4y equals negative 3x plus 16. What are we gonna do next? The 4. We're gonna divide. Divide everything. So y equals -3/4 x. I'm gonna rewrite this. I didn't do very well. -3/4 x. 16 divided by 4 is so plus 4. So those are our 2 lines. That's what's going on the graph. Ignore the stuff that they gave you. This is what we're gonna use.
Wait, okay. Yeah.
Giving everybody time to write this down. Talia's blind.
I know.
Yeah, she is. Okay, do we all have this written down? Okay. Oh, the phone.
FaceTime last night. Who did she?
I know.
Who is it? It's
No, I have to. This is
Okay, so we've got to graph these. It's in that back cabinet. Okay, so you're gonna need at least 5 spaces to the right, 5 spaces up, and 2 spaces down. Let's draw our graphs here. It's all right, just follow me. Yep.
We have to have it to the left.
No, not really.
I made it long.
All right, so we're gonna graph the red. I wrote it in red. You might not have. We're gonna graph the red line first. Where are we starting at?
No.
No.
-1.
-1. Always start with the number in the back. -1 is down here. Talia, how'd you know to go up 1 over 2? It's 1/2. So you go up 1 to the right 2. Wow, I can't keep this from moving. Okay, go up 1 to the right 2 a couple of times. You want to make sure you got a spot where your lines are going to cross. So you got to have a bunch of points.
I can't have a bunch of points. I have my writing in.
Okay, well, don't run into your writing. You'll be okay.
Yeah, my writing. I'm bad.
Okay, blue line. Where does it start? Four. So put a point at 4 on the y-axis. Okay, what is the slope? -3/4, which means we go down 3 to the right 4. Look at that. They cross. So our solution is here. What is that point? 4, 1.
I got it right.
What's up, Alana?
I don't know how to do that. My lines just don't go.
Why does it look like that?
Because I'm trying to go up, but it doesn't. It's a big one. Oh, but like, look, I'm trying to like.
Oh my gosh, you like that one.
Look at this one. Oh my God, side. It looks rough. And then these ones are supposed to be.
Okay. Are we all somewhere near ready to move on?
Yes. Yeah.
Lana, how's it going? I just know you had to catch up. All right, we ready?
Yeah.
Hey, I got this good offer. I've been offering all the classes. It seems like a lot of us have forgotten how to listen. I'm offering lessons after school. And some of I gotta be here till 4:15, whether you're here or not. Now everybody rats each other out. All right, so everybody got this down. All right, let's talk about another problem. So in these first two problems, what happened? They meet at 1 point, right? So now we need to talk about what happens if they don't ever cross or they're the same exact line. Okay, so we're gonna talk about some special cases now. So here's your new equation. 2y minus 3x equals 6 and 4y minus 6x equals 12. Okay. We need to rewrite these, right? Because as they are, not gonna help us. They are in standard form. Okay, we gotta rearrange them so that they are in slope-intercept form. So 2y minus 3x equals 6. We want y to be by itself. What do we need to do first? Oh, careful. Add the 3x, right? Because we want to leave the y on that side. We want it to be y equals. So we're always going to leave the y alone. Okay, that's gone. 2y equals 3x plus 6, because it was the positive 6. I need it to be y equals. How do I get rid of the 2? Divide. Divide every number by 2, right? So y equals 3 over 2 times x plus what's 6 over 2? 3. Okay, could you write 1.5x? Yes, but it's kind of a waste of time, right? Just write 3 over 2.
Yeah.
Okay, let's try it with the other one. We'll see. 4y minus 6x equals 12. How am I going to solve this one? Add 6.
Oh my god, I literally can't write.
4y equals 6x plus 12. What am I going to do next? Divide everything by 4. Y equals, is 6 divisible by 4?
3 over 2.
No, but you can reduce it to
3 over 2x
3 over 2x
plus 3.
plus 3. 12 divided by 4 is 3. Now, what do we notice about these equations? They're the same line. So could we graph these? Yes. Do we really need to? No. So what's going to happen if they overlap? Where are they going to cross?
In the middle. On the 3.
If I think about this, guys, if I have one line here, then I draw another line right on top of it, where are they going to cross?
On top of each other.
On the whole line, right? So do you want to write down every point that that line goes through? No, that's a pain. So we're going to write infinite solutions.
I even learned about that.
Okay, so when you have the same line, two of the same line, we write infinite solutions. We're not gonna graph that one. We don't need to. We know the answer.
Yeah, I do it.
Okay. One more example before we talk about some vocabulary. Yes.
I don't get how you draw bars.
Yeah, I just do a little.
Since I have a probability for you.
What? It's not even you.
Should be our new age.
You should be our.
You would be good, you could teach your math.
You should be
like
our
teach
teacher
us
for everything.
all the rest of the numbers, like you do.
We go back to like and you should stay our math teacher all for
Yes, and not have this happen.
I'll pay for any college you have to take.
Yeah, me too. We did that last.
I will go to college.
All right, write this down. What are we gonna have to do first, people? Put it in slope intercept form. Okay, so 3x plus 4y equals 12. Okay, what do I need to do to solve this? Whoa, 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 whoa. So subtract 3x because you want to keep the y on the side it's on. 4y equals negative 3x plus 12. Then what do I need to do? Divide everything by 4. We did a very similar one. Y equals negative 3/4 x plus 3. Okay, then what do I have to do? Rearrange the other problem. 6x plus 8y equals negative 8. What do I have to do first? Subtract 6x. 8y equals negative 6x minus 8 because it was negative 8. Okay, we're at this point. What's next? Divide everything by 8. Okay, so y equals 6/8 reduces to negative 3/4 x. And 8 divided by 8 is just 1. Okay, so those are the two new lines that we're gonna graph.
Oh my gosh, Mrs. Suits keep that up there for
I
literally my eyes are bugging out.
Maybe you need some glasses.
Shut up. I have glasses. I have them right now. Like they're like everything's bugging out. They are.
All right, let's graph the red line.
How many do you have to have on each side?
Let me see. You need 4 to the left and the right and 6 up and 6 down.
Oh.
4 to the left and the right, 6 up, 6 down.
I kind of intercepted all my other graphs, but it's fine.
Yeah.
4 left. 6 to the right.
4 left and right, 6 up and down.
That's what kids don't want to. Stop laughing at me. My frog.
We are. All right, looking at the red line. Where is it going to start? +3. Where are we going to go from there?
Down 3/4.
Down 3/4. Ooh, that was really bad, Doc. Let's try this again. Okay. Or you could go up 3 to the left 4. No, I just do it so you can see it.
Down 3.
Down 3/4. Okay, then the blue line, where's it starting?
-1.
And where are we going from there?
Down 3/4.
Down 3/4. Or you could go up 3 to the left 4. What kind of lines are these?
Parallel.
Okay, parallel lines. Are these ever going to cross?
No.
Okay, so when you get parallel lines, you write no solution. And that is your answer.
No pollution. No pollution.
No solution.
Number 5.
Questions on any of these 4?
No.
Okay, then we are going to talk about some characteristics of these graphs that you need to know. There's only 4 of them. So if you are anywhere near the bottom of the page, I would just start a new page.
So like, what about this?
You're probably fine. You're good.
Wait.
I'll give everybody a minute to finish up this page.
No. I don't know how to make pinwheels. That's all I would know.
All right.
That's all I would
All right, so new word. Consistent. Write it down. These are vocab words. Okay, write down these 4 words and then we're going to talk about them. Write down these 4 words. Consistent. What does it mean if something is consistent?
Always on time and always doing it.
Always on time, always like having an answer, right? Always prompt. I like that. Okay, so in math, if a system of equations is consistent, it's a system that has a solution. Right? They're consistent, they give you an answer. Has a solution. So what kind of lines would not be consistent?
Perpendicular.
Parallel. Because they don't have a solution, they don't cross. Okay. Then there's dependent. What does it mean if something's dependent?
It's on.
Dependent.
Oh, it depends on something else.
Depends on something else. So in math,
Here, have it.
why are we at this point? Like, just keep your hands to yourself. Okay, so what does it mean if something's dependent? It depends on something else. It needs something else to function. What kinds of lines? Well, not parallel.
Infinitive. That's-
Okay, I know what she means though. The ones that have infinite solution, right? Okay, that was one that was exactly the same line, right? So things that are dependent are systems. A system that has infinite solutions.
I'm good at
Because one line depends on the other. They have to be on the same line. Right? Okay, so we have consistent, we have dependent. Now we need to talk about inconsistent and independent. If consistent means has a solution,
That doesn't have a solution.
has no solution. Okay. If dependent meant it had infinite solutions. Okay, what's the opposite? What's the opposite of no infinite? It's not no solution, right? We already wrote down no solution. It has one solution.
Well, I guess it doesn't like fire itself.
Yes, independent by itself, one solution. Okay. So look at, just follow along. You don't have to write, just look. Looking at number one. Is that consistent or inconsistent?
Number one. It's inconsistent.
It's consistent. Why?
Because it has a solution.
Because it has a solution. So it's consistent. Now, is it dependent or independent?
Independent.
Why is it independent?
Because it only has one solution.
Because it has one solution. So if I ask you to classify this system on number one, you would say consistent, independent. Okay, number two, is that consistent or inconsistent?
consistent.
Consistent and dependent or independent?
Independent.
Independent, consistent, independent. Number three, is that consistent or inconsistent?
Inconsistent.
Inconsistent, and since it doesn't have an answer, we can't decide if it's dependent or independent, right? So it's just inconsistent. If you pick inconsistent, you're done. Okay. Number four, is that, wait a minute.
We just did number four.
So- Oh, okay, you guys did number four. Go back to number three. The one without the picture. If they're the same line, is that consistent or inconsistent? Consistent, dependent, because they're all the same answer. Okay, so tomorrow we're gonna pick up with 3 examples of this consistent, inconsistent stuff. And then we'll have a in-class activity and you'll finish the assignment that we're gonna start today. Today, all you gotta do, if you're looking at your Canvas homepage, the assignment for today is 6.1 practice day 1. It is due Friday at 3. So before everybody asks me, when you click on this, it will show you day 1 and day 2. You only need to do day 1 today. Okay, that's all you got left. Go for it.